This is probably the most detailed motorcycle deconstruction video on the entire internet. It will introduce you to every part of a motorcycle and their functions. The video is quite long, but after watching it, you instantly become a motorcycle expert. This is the motorcycle's engine, which provides the power for the motorcycle to move forward. This is the motorcycle's frame, which serves as the skeleton of the motorcycle. This is the ignition coil. The ignition coil is a very important and easily damaged component. Its function is to convert low voltage into high voltage, supply it to the spark plug, generate an electric spark, and thus ignite the air-fuel mixture in the combustion chamber. This is the engine's throttle. The throttle is controlled by the throttle cable and regulates the air entering the engine. The more you open the throttle, the larger the angle of this butterfly valve. One end connects to the engine's intake manifold, the other to the air filter, so it's also called the engine's throat. Since motorcycles all use intake-port fuel injection, their fuel rail is fixed onto the throttle body. The function of the fuel rail is to ensure an adequate flow of fuel and to evenly distribute the fuel to the injectors mounted on the rail. It can precisely spray gasoline into the intake port to participate in combustion. The fuel rail is connected to the fuel pump inside the tank. The fuel pump draws gasoline from the tank and pressurizes it. Then, through the injectors on the fuel rail, sprays the gasoline into the intake port to participate in combustion. This large black box is called the air filter housing, and it contains the air filter element. Its function is much more than most people imagine. Not only does it filter the air and extend the engine's lifespan, but it also has a breather hose from the catch tank connected to it. The breather hose allows the gases inside the engine's catch tank to be drawn into the engine for combustion in order to prevent environmental pollution. Moreover, a well-designed air filter housing can allow the engine to intake pressurized air at specific RPMs, thereby helping to adjust the engine's power curve. This is the engine's exhaust pipe. There are two oxygen sensors on the exhaust pipe, which are used to detect the oxygen concentration in the exhaust gases. If the oxygen concentration is high, the fuel injectors will inject more fuel. If the oxygen concentration is low, the fuel injectors will inject less fuel. This white aluminum box is the engine's main radiator, and the black component on top of the radiator is its fan, which is used for forced cooling. The radiator is connected to the engine via hoses. One hose connects the water pan at the bottom of the engine to the lower end of the radiators. It's the radiator's inlet hose. Another hose connects the upper end of the radiator to the upper part of the engine is the outlet hose. The principle of the water tank is the same as the principle of the open channel we learned in elementary school. The coolant inside the engine's water channels is driven by the water pump to flow in from the bottom and out from the top, allowing the coolant to fill the entire radiator and achieve a cooling effect. This is the engine's auxiliary reservoir. We can check the coolant level using the markings on the auxiliary reservoir. The factory auxiliary reservoir is connected to the main radiator by a thin hose. When the pressure inside the main water tank is too high, the spring of the water tank cover will be lifted up, and the coolant will flow into the breathing sound from this small hole, thereby balancing the water tank pressure. This black iron box is a whole container because the engine generates electricity as alternating current, and as the engine speed increases, the voltage will increase. So a whole container is needed to convert the alternating current into direct current, and adjust the voltage to about 14 volts. The wiring of this rectifier is 3 in and 2 out, which indicates that the engine's magnetocoil generates 3-phase alternating current. This small silver box is the engine's ECU, which is essentially the brain of the engine. The ECU receives various signals from the blue sensor, as well as information such as airflow, throttle position, cooling temperature, oxygen concentration, and so on. Based on these signals, the ECU calculates the optimal fuel injection point, ignition timing, and other parameters to control the operation of the engine. This is the motorcycle's fuse box, which contains fuses and relays. Its function is to protect the circuits and the electrical equipment. When there is a short circuit or the current is too high, the fuse will blow and cut off the circuit, thereby protecting other electrical devices from being damaged by excessive current. What this man in the blue shirt, who's actually a bit handsome, is showing everyone is not the legendary Kilowatt 3000. It's the main wiring harness of the motorcycle. It connects the electrical devices on the motorcycle with the generator and the battery. It is used to transmit electrical power. Although the motorcycle's main wiring harness looks very complicated, in reality, it is anything but simple. The high-quality Fei-Yin RM-certified motorcycle uses a European standard main wiring harness because once the main harness fails, it is very difficult to repair. This is the motorcycle's ABS pump unit, which contains solenoid valves and the ECU. The ECU receives the front and rear wheel angular velocity signals sent by the ABS sensors. By monitoring the rate of change of angular velocity, that is the angular acceleration, it determines whether the wheels are locked. For both the front and rear wheels, once a lockup is detected, the ECU sends a signal to the solenoid valve to automatically release the brake for you. It's extremely fast, so ABS can enhance our driving safety. The pump body of a dual-channel ABS has 4 holes. The large holes correspond to the brake oil pipes coming from the calipers, while the small holes correspond to the brake oil pipes coming from the master cylinder. The pressure of the brake fluid is adjusted in this way through the ABS pump body. This is the single-sided swing arm of a motorcycle. Assembling it may look complicated, and in fact, it really isn't simple at all. This is the eccentric cam of the single-sided swing arm. After long-term use, the motorcycle chain will stretch. If you don't want to throw away the stretched chain, you can only use the eccentric cam to adjust the wheelbase and barely keep things going. Inside the eccentric cam, there are 3 bearings, 2 ball bearings that handle the force from the sprocket, and 1 needle bearing that handles the force from the rear wheel. Because the single-sided swing arm is subjected to more complex forces, the needle bearing on the sprocket side has a relatively shorter lifespan, so we need to maintain it regularly. Now, what's being installed are this metal tube, which is the rear brake line, and this black wire, which is the ABS sensor wire. This black piece of rubber is the chain slider. It's used to prevent the chain from coming into direct contact with the swing arm. This is the main axle of the single-sided swing arm. One end is used to mount the brake disc, caliper, and rear wheel, while the other end connects to the sprocket. The 6 round pieces on the sprocket are sprocket dampers, which are used to cushion the power transmitted from the engine through the chain. This makes riding the motorcycle more comfortable and extends its lifespan. Inside the black retaining cap fixed to the sprocket, there are splines. These splines correspond to those on the main axle of the single-sided swing arm, ensuring that the power from the sprocket is effectively transmitted to the rear wheel through the axle. On the retaining cap, there is a locking nut, and the nut is equipped with an anti-loosening circuit. As long as this entire structure remains intact, we don't have to worry about the rear wheel of the single-sided swing arm falling off. Similarly, when installing the rear wheel, it must also be equipped with a locking nut and an anti-loosening circuit. This is the motorcycle's triple clamp. The structure is really very simple, and installation is also relatively straightforward. These 2 bearings are the key to allowing the motorcycle to steer smoothly. As for the brakes, wheels, tires, and the body panels, I'm sure everyone is already familiar with these components, so I won't go into further detail. Originally, I intended for this episode to be an assembly video, but due to my own mistake in not coordinating properly with my assistant, the assembly sequence ended up being rather disorganized. After editing the video, I realized that many viewers might not understand it, so I decided to change the topic of the episode at the last minute. If you'd like to see me do a disassembly and reassembly, or if you want to see more hardcore motorcycle content, please give me a like, comment, and subscribe. I'll do my best to keep updated.